Hi guys, so we have an O-level past paper question from the year 2016. The session is October-November. This is question number 11. In this question, we'll use the cumulative frequency curve to find the interquartile range plus a few more things and probability. So let's start. The question says 600 candidates took a mathematics examination which consisted of 2 papers. Each paper was marked out of 100. The diagram shows on the same grid the cumulative frequency curves for paper 1 and paper 2. Here's the grid. There are 2 frequency curves for both of them, paper 1 and paper 2. Part 1 says, use the cumulative frequency curve for paper 1 to find an estimate of A, the median. Okay, this is fairly simple. To find the median, first we need to look at this value over here, 600 divided by 2, that's 300. Draw a horizontal line at 300 for paper 1 and then draw a vertical line that connects that point over here on the x-axis, and this gives us 40. So the median for paper 1 is 40. The next part says the interquartile range. In order to find the interquartile range, you need to divide 300 into 2 parts. That gives us 150. 1, 2, 3, 4, 5. We draw a horizontal line at 150 over here to find the lower quartile, which comes out to be, let's see what it is. Let me be very precise with this. This comes out to be probably around 27. Okay, and then we have to divide 300 and add 150 to 300, which brings us to 450, which is over here. 1, 2, 3, 4, 5. Okay, so we draw a horizontal line over here and connect this point of intersection of the curve and the horizontal line with the x-axis. One second, where did it go? With the x-axis right here. Okay, so we have 52 over here and we have 27. So when we subtract 52 and 27, let's see what we get. 52 minus 27, this gives us 25. So the interquartile range is 25. The next part says the number of candidates who scored more than 45. So the candidates who scored more than 45, first of all, the 45th mark is going to be 1, 2, 3 over here. So we draw a vertical line over here. Connect this to paper 1. One second. So we draw a vertical line like this connecting to paper 1's curve, and then we draw a horizontal line over here. One second. And what do we have over here? We have 1, 2, 3, 4, 5, 6, 360. We subtract 600 and 360 and we get 240. Which is the number of candidates who scored more than 45. So we write it over here, 240. The next part says a candidate scored 60 on paper 1. Using both graphs, estimate this candidate's marks on paper 2. What we have to do over here is, since he scored 60 marks, so first of all, let's do this in blue. If he scored 60 marks, it is supposed to be on this vertical line over here. Now, if we connect a horizontal line to it like this, and we extend the line to B as well over here, and we draw a vertical line at the point of its intersection of the horizontal line and the vertical line somewhere around over here, it is going to be 80, 79 or 80 between them. So let's say it's 80. So the answer to this part would be 80. That's the candidate's marks on paper 2. Part 3 says state with the reason which you think was the more difficult paper. Of course, it's a very simple question. So paper 1 was more difficult. First of all, if we look at the median over here, it is lesser than the median that paper 2 would have. So the reason being, the median score for paper 2 was higher than paper 1. That's not the only reason. There must be other reasons. So one of the reasons that besides that I can highlight is that if you look at this value over here, this was 80 marks compared to 60 marks on paper 1. So this is also one of the reasons. So you can also refer to part 2, as it shows that paper 2 was easier than paper 1. Paper 1 is more difficult. Let's move on. Now we have a tree diagram. The question says Amira has three $1 coins and two 20-cent coins in her purse. She picks out coins at random, one after the other. The coins are not replaced. The tree diagram shows the possible outcomes and their probabilities when picking out two coins. This is the probability of the first coin and then the second coin. Part 1 says find X. Okay, of course, if one of the coins is picked out, that's a dollar coin over here, then only two coins are left out of 4, so the probability for X is 2 over 4. The next part says find the probability that the total value of the two coins picked out is 40 cents. So in order to be at 40 cents, you need to look at, you cannot pick out anything in this branch of the tree. However, you can pick out this and this because 20 and 20 make 40. So what you would do is you would multiply the probability of the two, which is 2 over 5 and 1 over 4. You multiply 2 over 5 and 1 over 4 and you get 2 over 20, which is your answer to this part, 2 over 20. The next part says find the probability that the total value of the two coins picked out is $1.20. So let's see. Let me remove all of this first. $1.20, that is what we have to make out of all of this. So $1 is over here and 20 cents would be over here. The same goes for this part, 20 cents over here and $1 over here. So first we do 3 over 5 times 2 over 4. We write it over here, 3 over 5 times 2 over 4, and add this to the probability of 2 over 5 and 3 over 4. So we do 2 over 5 times 3 over 4. Now let's see what we get. 3 times 2 is 6, 6 over 20, plus 2 times 3 is 6 over 20. This gives us 12 over 20, which is the probability for this part. Let's move on. At a car park, the charge is $1.40. Amira picks out three coins, one after the other. Find the probability that the total value of the three coins is $1.40. Okay, in order to do this question, first we have to come back to this tree diagram. Because she's picking out a third coin, that means we can draw branches over here. So perhaps she picks out another $1 and then another 20 cents, and then another $1, another 20 cents, another $1, another 20 cents, and another $1, another 20 cents. Now we have to make $1 and 40 cents out of it. That means if we pick out, one second, let's pick them out in blue. This, and this, we get $1.40. If you pick out this, and this, we get $1.40. And if we pick out, let's highlight the third one in black. So if you pick out this, and this, we get $1.40. So let's see the probabilities for these. So the probability over here is going to be 1 over 3 because you've already picked out two of the coins. Okay, and the probability over here would be, let's see what it is, 2 over 5 is gone, 3 over 4. Okay, so we have 1 over 3 over here as well. Okay, and then over here the probability would be 3 over 3 because she hasn't picked out a $1 coin yet in this chain. So let's multiply all of them together. First, the probability of the first branch, which is 3 over 5 times 2 over 4 times 1 over 3. So we write 3 over 5 times 2 over 4 times 1 over 3. And we add this to the second branch, which is 2 over 5 and 1 over 4 and 3 over 3. Sorry. Yeah, let's do that first. So we have 2 over 5 times 1 over 4 times 3 over 3. Now let's do the last branch, which is going to be 2 over 5 times 1 over 4, no, 2 over 5 times 3 over 4 times 1 over 3. Okay, now this is getting messy, but I still remember what these numbers are. So we do 2 over 5 times 3 over 4 times 1 over 3. That's how she picks up $1.40 out of 3 coins. So let's do this one first. What do we get? 5 4s are 20, 20 times 3 is 60 is the base, 3 2s are 6, plus 5 4s are 20, 20 times 3 is 60 is the base over here again, 6 and 2 times 3 is 6, plus I'm guessing 60 is the base over here, and 2 times 3 is 6. So the probability that we get is 18 over 60, and this is our final answer, and the question is done. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.